In this lecture, we shall learn 1. What is corrosion? 2. Effects of corrosion. 3. Classification of corrosion. Good afternoon, class. Hope you are doing well today.
Good afternoon, sir.
Please submit the assignment I had asked you to do last lecture.
Sure, sir.
Great. Let us start a new chapter today. Its name is Corrosion and Prevention. You must have heard about corrosion in various contexts.
We have so many nails, metal pieces in our backyard. They are just laying there and getting rusted. Is it a corrosion?
Yes, indeed, it is a corrosion.
Thank you.
Corrosion can be viewed as a universal phenomenon. It is there everywhere: air, water, soil, and in every environment we encounter. Corrosion has a huge economic and environmental impact on all facets of national infrastructure, from highways, bridges, buildings, oil and gas, chemical processing, water and wastewater treatment, and virtually on all metallic objects in use. Other than material loss, corrosion interferes with human safety, disrupts industrial operations, and poses danger to environment.
Sir, can you define corrosion?
Yes. Corrosion is the deterioration or destruction of metals and alloys in the presence of an environment by chemical or electrochemical means. It also can be defined as the process of decay of metal by environmental attack. For example, iron undergoes corrosion to form reddish-brown color rust, Fe2O3.3H2O. Copper undergoes corrosion to form a green film of basic carbonate.
May I interrupt?
Yes, sure. What is it, Shilpa?
What are various effects of corrosion?
I appreciate your inquisitiveness, Shilpa. Keep it up. Corrosion may affect adversely on metal as following. 1. Wastage of metal in the form of its compounds. 2. The valuable metallic properties like conductivity, malleability, ductility, etc. are lost due to corrosion. 3. Lifespan and efficiency of metallic parts of machinery and fabrications is reduced.
Sir, will you explain me the classification of corrosion?
Very good question, Shilpa. Primarily, corrosion can be classified into two categories: 1. Dry corrosion or chemical corrosion, and 2. Wet corrosion, or electrochemical corrosion, or immersion corrosion. Let us see each category in detail. The first category, that is dry corrosion, occurs mainly through the direct chemical action of atmospheric gases, like O2, halogens, H2S, sulfur dioxide, N2, or anhydrous inorganic liquid with the metal surface. Dry corrosion is of three types: 1. Oxidation corrosion, 2. Corrosion due to other gases, 3. Liquid metal corrosion.
Will you explain each type one by one in detail?
Yes, I will. Let us see first type, that is oxidation corrosion. Essentially, this is carried out by the direct action of oxygen, either at low or high temperatures, on metals in absence of moisture. This leads to formation of oxide layer on the surface of metal. The type of oxide layer formation depends on the metal on which it is getting formed.
Sir, will you elaborate this point?
Yes, sure. Basically, there are four types of oxide layers are being formed. 1. Stable oxide layer. A stable layer is fine-grained in structure, and can get adhered tightly to the parent metal surface. Such a layer will be impervious in nature, and hence behaves as protective coating, thereby shielding the metal surface. Consequently, further oxidation corrosion is prevented.
Can you give some examples of metals which forms stable oxide film?
Aluminum, tin, lead, copper, etc. form stable oxide layers on surface, thus preventing further oxidation.
That's interesting.
Second type is unstable oxide layer. The oxide layer formed decomposes back into metal and oxygen. Consequently, oxidation corrosion is not possible in such cases. For example, silver, gold and platinum do not undergo oxidation corrosion. The third type, which is volatile oxide layer. It is volatile in nature and evaporates as soon as it is formed, thereby leaving the underlying metal surface exposed for further attack. This causes rapid continuous corrosion, leading to excessive corrosion. For example, molybdenum forms volatile molybdenum trioxide layer. Lastly, the fourth type is porous oxide layer, which contains pores and cracks. In such a case, the atmospheric oxygen has access to the underlying surface of the metal through the pores or cracks of the layer. Thereby corrosion continues until the entire metal is converted to its oxide. For example, iron, when attacked by H2S at high temperature, forms porous FeS layer.
Very well explained, Dr. Sheikh.
So far we have seen dry corrosion and how oxidation corrosion lead to the various types of oxide films. Corrosion due to other gases can further be classified into three subcategories. 1. Corrosion due to hydrogen, or hydrogen embrittlement. 2. Corrosion due to other gases than hydrogen. And 3. Decarburization. First, we are going to see hydrogen embrittlement, or corrosion due to hydrogen. Loss in ductility of a material in the presence of hydrogen is known as hydrogen embrittlement. This type of corrosion occurs when a metal is exposed to hydrogen environment. Iron liberates atomic hydrogen with hydrogen sulfide in the following way. Hydrogen diffuses into the metal in its atomic form, and gets accumulated in the voids present inside the metal, which further combine with each other and forms hydrogen gas. Collection of these gases in the voids develops very high pressure, causing cracking or blistering of metal.
Thank you so much for explaining.
Now we are going to see second type, in which corrosion occurs due to other gases than hydrogen. This type of corrosion is due to gases like sulfur dioxide, CO2, Cl2, H2S, F2. In this corrosion, the extent of corrosive effect depends mainly on the chemical affinity between the metal and the gas involved. For example, when silver comes in contact with corrosive chlorine fumes, it undergoes corrosion, forming silver chloride layer. In petroleum industry, H2S gas at high temperature reacts with steel, forming FeS scale. The same is true for other gases such as sulfur dioxide, CO2 as well.
Very well explained, sir.
Third type of corrosion due to other gases is decarburization. The presence of carbon in steel gives sufficient strength to it. But when steel is exposed to hydrogen environment at high temperature, atomic hydrogen is formed. Atomic hydrogen reacts with the carbon of the steel and produces methane gas. Hence, the carbon content in steel decreases. The process of decrease in carbon content in steel is known as decarburization. Collection of methane gas in the voids of steel develops high pressure, which causes cracking. Thus, steel loses its strength. Now, we shall learn about liquid metal corrosion. This corrosion is due to chemical action of flowing liquid metal at high temperatures on solid metal or alloy. The corrosion reaction involves either dissolution of a solid metal by liquid metal, or internal penetration of the liquid metal into the solid metal. For example, coolant, in this case sodium metal acting as coolant, which leads to corrosion of cadmium in nuclear reactors. Now, let me summarize various points we learned in this lecture. We have seen what is corrosion and what are ill effects of it on metal. Then we learned Corrosion primarily can be classified in two categories. 1. Dry corrosion or chemical corrosion, and 2. Wet corrosion or electrochemical corrosion or immersion corrosion. Dry corrosion can further be subclassified into 1. Oxidation corrosion, 2. Corrosion due to other gases, and 3. Liquid metal corrosion. In case of oxidation corrosion, various types of oxide films or layers, such as stable layer, unstable layer, volatile layer and porous layer, are formed based on nature of metal.
Thank you, sir. I must appreciate your efforts and energy put in to simplify and explain this topic to the class.
You are welcome.